Alright guys, welcome to another video on the Crazy Apple channel. And then today we have an exciting video, and this video is why does the data path cycle have a huge impact, on the performance of the CPU. So let's talk about data path. Data path cycle plays a crucial role in CPU performance because it directly influences how efficient data moves from the CPU's various components during instruction execution. So as you can see, the data path is like, it plays a major role in the data instruction execution. So the efficiency of data path cycle can have a significant impact on the overall speed, throughput. I'm probably sure by now you know what throughput is, and executive time of instructions. Here are key reasons why the data path cycle has a huge impact on performance. Alright, so first of all, we have the instruction throughput and cycle time. So the cycle time is the clock cycle of the fundamental unit of the time in which CPU relates or operates. And then the data path cycle determines how long it takes to complete one cycle of an instruction. If the data path is designed inefficiently, it could result in longer cycle time, reducing the number of instructions the CPU can execute per second, which is also called the throughput. You get it? So the pipeline stages. Modern CPUs break instructions processing into multiple pipelines stages. So that's the instruction fetch, the decoding, executing, and then the memory and write back. So the efficiency of these stages determines how quick instructions can pass through a data path. If one stage takes longer to complete, it delays the entire pipeline. So the pipeline has a couple of stages, which if one delays, it might affect the whole time pipeline. You get it? So in order for it to influence the CPU, everything must be on point. You get it? So when it comes to pipelining efficiency, we've literally spoke about it. It allows multiple instructions to process in parallel. So that's what basically pipelining is all about. Such as a slow or poorly designed AUL can cause pipeline to stall. So next thing is the hazards, data hazards, where one instruction depends on the results of previous instructions. And control hazards such as branch instruction can disrupt the smooth flow of instructions in the pipeline. If data path is not optimized to handle these hazards efficiently by using forwarding and branch prediction, it can result in pipeline stall. So what it basically means pipeline stall is what we spoke about in the previous slides, which is the one stage will delay every other process, will delay the entire pipeline process. You get it? And data transfer speed. So that's also one factor that affects the CPU. You get it? So we have the data transfer speed, data movement. The data path involves the movement of data between register, memory, functional units like the ALU, arithmetic logic units. If path has carried data between these components are slow and limited in bandwidth, yes, it can create, you get it, a whole lot of problems. So register file and the ALU. In the CPU, registers are used to hold intermediate values during computation, and the ALU performs arithmetic or logic operations on them. So that's basically what happens at the data transfer speed. And then we come to memory access latency. We have memory store. The data path cycle also determines how efficient the CPU interacts with memory. Memory access can also be slow due to the latency, especially when dealing with the cache misses and accessing main memory. If the data path is not assigned to handle memory access efficiently with multiple levels of cache or fast memory buses. Yeah, I'm sure you know what buses are. They're serial that connects components in the systems together. It can significantly slow down the entire process. So basically, what we've learned so far is if any of these processes have any effect in any of these processes, that's the pipelining, data transfer speed, all these processes, it can literally affect the whole CPU. How do you call it? So yes, that's basically it. Then we come to the cache misses. A poorly optimized data path can bro, you guys should take your time. This presentation. Okay, so if the CPU has to wait for data to be fetched from the main CPU, which is slower than cache, it also delays in the pipelining and reducing CPU performance. So if you have any questions, I can make a second video on this, so you can just leave a comment or anything. So the next point is also instruction latency. Execution time, that's basically the time it takes for an individual instruction to move through the entire data path cycle from instruction fetch to write back. It is critical in determining how quick a CPU can complete a task if the data path is insignificant or too complex. So complexity of an instruction can also take long to execute, which reduces the overall performance of the processor. More complex instructions such as those that involve floating points, calculations, those big maths, your friend is saying, a whole lot, you get it. So it will take longer to transverse the data path. Efficient data path reduces the time needed for complex instructions. So more efficient data paths will mean this complex instructions will be a no problem for the CPU to handle, leading for a better performance. Clock speed and data path design. Clock speed limitations. The clock speed of the CPU determines how fast the CPU operates, but this speed is constrained by the longer stage in the data path. Yeah, so you should understand, it's self-explanatory. The cycle time of the longest stage, often called critical path, take note of this word, critical path, limits how fast the clock can be. And let's go to the trade-off. CPU designers have to balance the complexity of data path, which is desired clocks with the desired clock speed, or a more complex data path with more components. Example, additional pipelines and more functional units may reduce the maximum functionable clock speed due to the longer cycle time. And then we have superscalar architecture and data path width. This is quite complex, so you need to like do more research on it in order to understand it more. So multiple instruction execution. So you know what, I'm just going to leave this part because this is more. Let's skip to the resource utilization. The more efficient the data path allows the CPU to utilize its resources, like multiple ALUs or loads or store units, the better the overall performance, kind of a mistake here, will be, as the CPU can execute multiple instructions. And just in case, if you want the file to the PDF to this, you can hit my email up on breakoutlamponsa@gmail.com. So yeah, thank you. So the efficiency, so now we come to the logic unit. You get it. Control hazard. In modern CPUs, control hazards are handled by branch predictions unit. If the data path cycle involve an inefficient or slow batch prediction unit, it causes delay as the CPU waits to resolve the branches. Yeah. The accuracy and speed of branch prediction significantly affect CPU performance. So to conclude everything, the data path cycle is essential to CPU performance because it governs. So basically, this is what the whole concept of what I've been trying to talk about this video is all about. So it governs the time and resources needed to process and move data through various stages of the instruction execution. Yes. So that's the work of the data processing and all that, and how the CPU enhances it. Efficient data path design, along with strategies like pipelining, data forwarding, and batch prediction, is crucial for minimizing delays, increasing parallelism, and maximizing throughput. Yeah, throughput once again. Any inefficiencies or any problem, whether due to slow memory access, data hazards, or anything, can literally reduce the CPU's performance. Thus, optimizing the data path is one of the primary ways to achieve a higher performance in memory processing. So thank you very much. This is Crazy Apple Kalitech. Come back more for more videos. Please leave a like, subscribe, and then see you in the next video. Bye.